projectile, and we don't have anything to do with that. So the answer to this question is option B. Question number 15. The graph above describes the motion of a particle. The acceleration of the particle during the motion is, you can see the graph. This is the graph we are referring to for question number 15. We have to calculate the acceleration of the particle during the motion. If you look at this graph, this is a uniform acceleration, this is a uniform velocity, this is the uniform retardation. So if you have to calculate the acceleration now, is from here to here. And acceleration A is equal to velocity over time. This column is for velocity, this column is for time. So between 10 and 2 will be our velocity, then between 0 and 2 will be for time. So which means we are going to have 10 minus 2, 2 minus 0. And 10 minus 2 will give us 8. 2 minus 7 will give us 2, which is equal to 4 meter per second squared. And that is the value for acceleration. Let's consider question number 16. The question says, find the total distance covered during the acceleration and retardation period of the motion. We are referring to this figure. This is the acceleration. This is the retardation. In short, the first triangle here is representing the acceleration. The triangle here is representing the retardation. So to find the distance covered for acceleration is as simple as calculating for the area of this triangle. For acceleration, the distance covered, call it x1, will be equal to half base times height, the area of this triangle, which is equal to half. The base will now be your time in between 0 and 10, which is going to be times 10. Then the height will be your velocity between 10 and what? 0, which is 10. Which is equal to, this is going to be 2 here 1, 2 here 5. And what you are having is 50 meters. That is for acceleration. For retardation, the distance covered, call it S2, will be equal to half times base times height for the second triangle, which is going to be half. The base will be in between 40 and 45. You are going to look for 7 from 40, you are having 5. The height is still in your velocity side, which is 10. 2 here 1, 2 here 5, then you are having 5 times 5, 25 meters. But what the question says is this. The question says we should find the total distance covered. Total distance will now be equal to addition of S1 and S2. And our S1 is 50 meters. Our S2 is 25 meters. Altogether, we are going to have 75 meters. And that is the solution to question number 16. Question number 17. The diagram shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are, look at this diagram. Question number 17. It's the same diagram with what we have been dealing with. This is the velocity, this is the time, this is the acceleration, this is the retardation. So we are going to calculate the acceleration separately, retardation separately. And that is what the question is saying. What will be the acceleration and retardation respectively? So the acceleration A is velocity over time, which is equal to, for velocity is going to be 80 minus 0 divided by 20 minus 0. And this is going to be 80 divided by 20, which is going to be 4 meter per second squared. For retardation A, which is the negative of acceleration, it still be equal to velocity over what? Over time. But in this case, we are still going to have our 80 and 0 for velocity. 80 minus 0, then the time will be in between 90 and 50. 90 minus 50, which is 80 over 40, which is 2 meter per second squared. So, for both acceleration and retardation respectively, we are going to have 4 meter per second squared, 2 meter per second squared. And that is what you are to do. Question number 18. The question says a body is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is the maximum height. The first thing you have to note about the projectile is about all the equation we use in projectile. We have something we call maximum height. We have another term we call time of flight. Then we also have what we call the range. But for the maximum height, h is equal to u squared sine square theta over 2g. That's the equation for the maximum height. And your u is the velocity. This is the angle of projection. Your g is the value for acceleration due to gravity. So this is a simple substitution for maximum height to be equal to, we are given the value for velocity, which is equal to 80 meters per second squared. We are going to have 80 squared sine square 30 divided by 2 times 10. This is 80 squared times, this one is as simple as sine 30 times sine 30 divided by 20. If you continue, sine 30 is 0.5, 0.5 times 0.5, all divided by 20. And this is the 80 squared, in this case, because 8 squared is 64. This is 6,400 times 0.25, all divided by 20. 0 can lose 0. In 64, in 60, that's 30. In that's 32. 320 times 0.25. If we try to make use of our mathematical instruments, we are going to have 320 times 0.25, and the answer is 80 meters. 80 meters. Question number 19. Two bodies X and Y are projected on the same horizontal plane with the same initial speed, but at an angle of 30 degrees and 60 degrees, respectively, to the horizontal. Neglect here resistance. The ratio of the range of X and Y is, the formula for the range is equal to u squared sine 2 theta over g. We are not dealing with two bodies. They say what will be the range, the ratio of the range of both X and Y. So for the range of X will be equal to u squared sine 2 times 30 degrees divided by g. And for Y, range of Y will be equal to the same u squared sine 2 times 60 degrees divided by g. Okay? In this case, we are now looking for the ratio of both ranges of both x and y. And you know the ratio can be taken in terms of fraction. You can now say range of x over range of y will be equal to, but in this case, we have u squared, we have u squared. It can go for each other. What we are having left is for x, sine 2 times 30 degree over sine 2 times 60 degree, which is equal to sine 60 divided by sine 120. And if you point your calculator, we are going to, for this one, it's going to be 0.8660. And the same thing for sine 120, 0.8660. And if you look at this one very well, 0.8 can be approximated to be 1. The same thing for this one. That is, the range of x and the range of y will be in ratio 1. 1:1. If you are to write in terms of ratio s, the range of s ratio range of y is equal to 1:1. And that is the solution to question number 19.